Hello, everyone. Welcome to our section, Data Integration and Effectiveness of Pipeline Integrity Management Programs, which will be part of the Integrity Program of Rio Pipeline in 2021, organized by Instituto Brasileiro de Petróleo, IBP. Let me introduce myself. My name is Ellen Costenaro. I am a chemical engineer with PhD in electrochemical by University of São Paulo. I am integrity engineer at Comgás, working with steel pipeline defects analysis, inspections, pipeline repair, and cathodic protection. I want to thank IBP for inviting me to mediate this section. It's a great pleasure for me to be here. So in this section, we are going to have 3 lectures, one followed by another, and the questions will be made in the end of these 3 lectures. I kindly ask you, if possible, to send us your question in English by the chat. The speakers have about 10 minutes and 10 minutes each one, and then 15 minutes for questions. I also would like to introduce Rodrigo Soares, who are supporting me with the question. Rodrigo is an electrical engineer with an MBA in Strategic Management of Production and Maintenance, Masters in Electrical Engineer in Modeling and Analysis of Power System, both by Fluminense Federal University. Rodrigo has solid professional experience in the area of maintenance of gas networks, pipeline integrity, and cathodic protection. He is currently the Integrity Coordinator at Transportadora Associada de Gás, TAG. So let's start now. The title of the first lecture is Why a Remote Monitoring System in the Protection Cathodic? The speaker is Antonio Horta Costea. He is head of Asset Integrity at NetRia. It's a Network Spain group. Antonio has been working as industrial electronic engineer since 1986. In 1987, he joined Catalana de Gas y Electricidad, currently NetRia Network Group. Antonio is member of CEOCOR, European Committee for the Study of Corrosion and Protection of Pipes and Pipeline System Drinking Water, Wastewater, Gas and Oil, and representative of Spanish Gas Association, SEDGAS, in the CEOCOR Board Directors. He is member from the Technical Committee CTN 112 of Iron Corrosion and Protection of Metallic Materials. He is member of Pipeline Integrity Working Group of the Spanish Gas Association, SEDGAS. In these 3-4 years of working life, Antonio was for 10 years head of Cathodic Protection Department, responsible for the implementation of SAP-PM Maintenance Management System. He was responsible for the implementation of the Cathodic Protection Remote Management System Network Group, which includes Spain, Italy, Brazil, Mexico, and Colombia. In 2018, he worked in the implementation of dynamic maintenance in cathodic protection in NetRia. And now in this year, he is the product owner for the implementation of dynamic maintenance in other maintenance activities, such as leak monitoring, emergency care, maintenance of LNG plants in NetRia. So Antonio, please, the floor is yours.
Thank you very much, Helen. I will read my presentation because my English is a little correct for this pandemic. Hello, ladies and gentlemen. I will talk about the reasons why remote monitoring system is necessary in the cathodic protection maintenance. The teacher asks a question, what happens to iron when it corrodes? The student answered, it's ugly. That's true. But maybe we have a leak in the pipeline. And sometimes this is the reality. I always tell my coworkers that our mission is neither cathodic protection nor a remote monitoring system. Our aim is to safeguard our pipelines against electrical corrosion. The NetRia Network Group is a natural gas transmission and distribution company in Spain. In the map and in blue, you can see the dispersion of our gas pipelines in the geography. we have 8,000 kilometers of steel pipeline with cathodic protection. It is protected by 450 rectifiers, 25 DC current returns, 50
Antonio?
Yes?
Antonio, sorry to interrupt you, but I think we cannot able to see your presentation.
No?
Did you share it?
Sorry, excuse me.
Okay.
Now you see? Sorry.
Yes, no, it's okay.
I normally I use in our company the Teams, and the Zoom is the first time I use. Sorry. Introduction. Sorry. We have 8,000 kilometers of steel pipeline with cathodic protection. It is protected by 450 rectifiers, 25 DC current returns, 50 AC air wire, and 70,000 control points. All the rectifiers, CD current and returns, and AC air wire has a remote monitoring device, and 1,800 control points too. From static maintenance to the dynamic maintenance. The normative says that every X days, the cathodic protection parameters must be measured, and every Y weeks, other processing must be done. But these standards are independent of the pipeline's characteristics and their particularities. I think everybody agrees that a submarine pipeline at 45 bar maximum operating pressure is not the same as a pipeline in a village at 4 bar maximum operation pressure. It's the same example as bicycles. In the first one, only the man's strength is taken to account, static, like the actual normative. In the second one, the man decides what is the best way to use his strength, dynamic, the future of maintenance. The importance of the data. At Nokia, we thought we needed a parameter to measure the effectiveness of cathodic protection. I think everyone agrees that traditional measurements are not enough for building an algorithm to respond to dynamic maintenance. Therefore, in 2009, we decided to implement a remote monitoring system for cathodic protection. Cathodic protection efficiency parameter. This algorithm is based on the time rule. CATI depends on 4 variables. CAR-R evaluates the pipeline's characteristic. This parameter is a function of the pipeline's length. KI evaluates the cathodic protection installation characteristics, rectifiers, DC current returns, AC earth wire, and control points. KREC evaluates the time the rectifier is in service. And KM evaluates the measurements, remote and technical monitoring. The sum of their 4 variables defines CATI. If CATI is above 75 points, the effectiveness of the cathodic protection is adequate. If CATI is between 61 and 75 points, the cathodic protection zone maybe have a problem. And if CATI is below 16 points, Houston, we have a serious problem. Thank you very much. Any questions?
Antonio, the questions we're going to have in the end of our 3 lectures.
Okay.
Now we are going to the second lecture of this section. The title is Using Software for Online Integrity Management. It will be presented by Alexandre Zewald, who is a technical consultant at Transpetro. Alexandre is pipeline integrity engineer with 15 years of experience with pipelines. Alexandre leads the management of stress corrosion cracking within Transpetro and also works with defect analysis and pipeline repairs. He has a strong background in pipeline hydraulics, hydrostatic test, location class, and field assistance. Recently, Alexandre has also been working on a project for data integration and integrity management software. Alexandre, you have the floor.
Hello, Ellen. Thank you. So I'll be talking today about the use of software tools for integrity management in the view of a pipeline operator from Transpetro point of view. So I would like to kick off by saying that Transpetro is recently spending a lot of time and effort in implementing a solution for integrity management. That is a bundle of software tools that interconnected will help our integrity management program. We can call it a digital transformation process within Transpetro, but it's from digital to digital. We were already digital since they're already around 2000, and now it's a step further into a digital transformation. So what I can bring to the audience today is the context in which an integrity management software can assist the integrity management program and integrity management engineers. So during this process, our team has developed many insights and the foundational concepts that helped us build this project. So that's what I'm trying to bring for the audience today. So the starting point of this this process is the four-step process for the integrity management program. Like the PDCA, plan, do, check, and act process, we have a similar process for the pipeline integrity management, which is the cycle I'm showing here. It all starts with the data integration. So data integration is the starting point. And if you have a good data and you can integrate them, you can perform a risk assessment. And once you perform a risk assessment, you can follow on and build your integrity assessment. And next to the integrity assessment, you go to the field actions and implement those actions that those assessment has defined previously. So this is basically how I see an integrity management software working. So you can see here the gears, and the driver gear is data integration. Data integration moves the risk assessment, in which moves the integrity assessment. And the integrity management software help these gears work with less friction, let's say. So you can ask me, what is the great deal about data integration? Well, I can say that it's a great challenge. If you say, you can see here in this photo here, this could be the pipeline integrity engineer looking at different data sources that he receives from the field. These data sources come in different references, different formats, and he's trying to recognize what the data is telling him, and he's trying to come up with well-informed decisions. So here you can see that different references from different sources of data. For example, the right-of-way people, the right-of-way inspection uses the right-of-way posts as a reference. On the other hand, the inline inspection can use the odometer of the tool as a reference. And other inspections can use the very coordinate from the geographical reference. So how can you couple and integrate all this data that comes in different references? You also have in the organization different sources. You have your data, enterprise resource planning. Some organizations use the resource planning as a tool for data integration. you also have your electronic document management system as a source, and also your GIS. I would also mention that some companies still have electronic files and hard copies as a reference, but I'm presuming here that it's not ideal for the implementation of integrity management software. And this software, or this set of tools, also have to show the specialist different formats. This guy needs to see data in maps, in graphs, and in tables. Okay? And he's thinking, information integration is a key component for managing system integrity. This is a bold statement from this standard here. Okay? So what do we need to start doing this? We need good data. So in this screen, I'm showing a scale that our team has developed to measure the level of maturity that we have, or you have. Each one of you can apply this to your team or to your process. How mature is the data you're generating? So on the first level, your data is complete, is verified, and is approved. On the second level, your data is also available on a corporate system. Why is that important? Because then you have revision control and your document is trackable. On the third level, your data is standardized. So every document that is generated with the same results are always on the same format. Why is that important? Because the automatic extract, transfer, and load processes are automatic. The fourth level would be if this data is geo-referenced, then you can put it on a map and you can cross them with all other sources on a single reference. And the fifth level of maturity would be if that data is integrated across all the softwares you have working in your organization. So if the inspection is recorded on one system, but the integrity engineer needs that data in another system, the systems are seamlessly transferring data without manipulation. So we have internally, we consider that the fourth level of maturity is when we would be ready to implement an integrity management software. That's how we need to be mature about our data. And in the context of an integrity management program, we consider that a software tool needs to have a certain set of characteristics. Well, the first one would be that the database is unique. So all analysis, you name it, ILI analysis, risk, external corrosion, all are collecting data from a single source. So that assures lower effort for that integration and less human error in the manipulation of this data. The third characteristic is be geo-referenced. I remember the first time I saw Google Earth working, and we cannot go back to how it was before that. Our data is geo-referenced. We can see it on maps, tables, and graphs. The fourth characteristic, it would be to the system or the software to be connected, and that is connected to other corporate systems, interconnected within our organization. The fifth characteristic would be to generate business intelligence panels, like this one, for example. And if it's connected, it can generate online BI panels. That has much value to stakeholders. And the sixth characteristic, and I believe this is the most important for the integrity engineer, is that the system to be customizable. Because every company has its own way or its particularities as how you assess your integrity. And your solution needs to be molded to that. It must be customizable. And the values you get to the stakeholders are fast response and timely information. Both your external clients, your internal clients give much value to that. You will also have standardized results, and you'll be ready for whatever comes next. I've heard about big data or artificial intelligence. Mr. Herman Rosen was talking about a little bit about that. I don't know what's coming. Maybe it's coming, but if you're not in this maturity level within your integrity management program, you will not be ready. And of course, when you're going to implement such an integrity management software or bundle of softwares, you have to overcome some hurdles, right? So I've listed here 5 steps for the implementation. First ones are hardware and software. I would point out that the most important feature is that whatever set of solution you define, you have don't forget about connecting every software that you have working together for your integrity management program. Connection is the great word here. Third one will be data. Then you can refer to the maturity level I've already discussed. And of course, a great initial effort will have to be put on place, because it's a huge amount of data that you're going to need. And then you're going to need documents of your pipeline. It seems obvious, but it's not trivial to do that. To take documents from the 70s, the 80s, and digitalize and register on your database. It is a great initial effort. Then comes people, right? So your colleagues, your stakeholders, your clients, they have to be with you. They have to be on board. They have to think that this is a good solution that will improve the company. And you also need sponsorship from your management. Okay, this is very important for the implementation. And then, of course, training. We actually are in this point here on our solution implementation on training. A big amount of training is required, and I'm seeing that everyone has its agenda full, and you still have to put on a lot of training. So this is a very challenging step here. And the fifth and most times forgotten step is the workflow. If you do not define workflows that put this integrity management software or solution, as you name it, within your organization and workflow, making this solution part of the routine within your procedures in a standardized manner, I think that the software will fade out and maybe sometime will not be that much used anymore. I guess all the audience have been part of projects that you have invested a lot of financial effort, install a software, and maybe 2 or 3 years after that, the software is no longer in use. No one trusts the software. So I think that this last step of putting the software into the workflow of your organization is key to assure a long-term use of the software and make the best use of the solution. Okay, so as concluding remarks, I would say that an IMS, integrity management software, of course, can bring benefits to an organization. Never forgetting that it has to be integrated with all other corporate systems that you have. And it's important also to align expectations, both from the management and both from your colleagues, to know that the software alone will not assure pipeline integrity. It's a tool, it's one of the tools you have. And the key component that will help pipeline integrity is data, good data. Okay, the maturity of your data will be fundamental on the assurance of pipeline integrity. Another aspect that is important is engaging people that will be using the software, will be migrating from one set of tools to another set of tools, a new set of tools. And for that, it's important to define these workflows that can be responsible for this active use of this software in the long run. Okay, so with that, I'll conclude my presentation and go back to you, Helen. Thank you very much.
Thank you, Alexandre. And the third and last lecture of this section is data integration for risk analysis in integrity management, which will be presented by Marcos Bartelotti. Marcos is TBG technical consultant. He's a mechanical engineer from Federal University of Pernambuco, graduating in 1997. He has 24 years of experience in the design, construction, inspection, maintenance, and integrity assessment of transportation pipelines. Since 2006, he has been working for TBG, owner and operator of the Bolivia-Brazil gas pipeline in Brazilian territory, working in different activities of the pipeline integrity management. Marcos, please.
Thank you, Ellen. Good afternoon, everyone. Can you see my screen?
Yes.
Okay. Well, this presentation is based on TBG's experience in implementing a risk assessment system for the pipeline. So when deciding to implement an integrity management program based on international best practices, the road starts with the pipeline threats identification, data gathering, and risk assessment. At this stage, it's very tempting to believe that buying an integrity software is the magic solution to this new management process. So let's look at these three initial steps and its challenges. First, threat identification. Potential threats can be identified in international standards, statistics, and in the experience of subject matter experts. A list of variables must be established. Their function is given information about the level of exposure, the existing mitigations, barriers, and the resistance of the pipeline. In an analogous way, we must also identify those variables that represent the consequences of a pipeline failure. Then we start with the data gathering, a subject that Alexandre explained excellent previously. Data comes from all available sources, design and construction documents, inspection, prevention, and maintenance activities, also from operation monitoring systems, and from subject matter experts. Advancing technology is bringing new data-rich sources. For example, regulatory agencies are providing shapefiles of authorized areas for mining exploration. This gives us information on possible blasting activities close to the pipeline. Another technology already in use is known as building footprint. Applying machine learning on satellite images, it detects buildings and its geographic coordinates. Then, with the help of GIS tools, we determine the distribution of buildings within the impact radius along the pipeline. Following a digital transformation process, TBG initiated a right-of-way inspection project with drones. Again, artificial intelligence over images identify elements in the right-of-way associated with risk variables. The high resolution is such that it's capable, for example, to automatically identify power lines or damaged sign marking, and many other elements. As all the generated information has geographic coordinates, we can upload them to the risk assessment database. Talking about data integration. Increasingly, data comes from different sources in different formats. And again, Alexandre presented it greatly before. I want to just add and stress that to complicate things, a lot of data is generated with different positioning or mileage systems. So to integrate data, we found a few options. Put everything into spreadsheets, or upload to an integrity software, or to a server database, or more recently to the cloud. In one hand, it's required to ensure data integrity. I mean, data cannot be easily changed or lost. On the other hand, database should not be too complicated for uploading, editing, querying, and sharing data with other systems. TBD chose a pre-existing Oracle database running on a corporate server. This solution resolved the data integrity issue, as well as the possibility of sharing with other systems. To make it accessible to integrity engineers and technicians, a web GIS tool was developed. It allows users with no knowledge of database or even GIS to manage the risk data. Upload and editing can be done manually or in batch using CSV spreadsheets. Query results are presented as tables or graphically in pipeline imagery. Once data management system was defined, let's talk about the risk model. Selecting the risk model is maybe the main issue in the risk assessment implementation. Unfortunately, the traditional risk assessment methods widely used in industry, including oil and gas installations, are not feasible for pipelines. One of the main reasons is because pipelines are linear assets. This means that variables change along the length of the pipeline, so risk changes. Therefore, other methods capable for dealing with these characteristics are needed. A recently published report by FEMSA, the American regulator, based on the evaluation on pipeline operators' practices, classified the used risk models into three types, basically. The relative index score model, the quantitative model, and the probabilistic. The relative one, widespread among operators, has a qualitative or numerical input without units, an index, in other words. The results are also numeric, unitless, a score. Algorithms basically consider the index of each variable multiplied by its relative weight. Moving to the quantitative model, the input now has units. So results are presented in absolute terms. A great advantage is that this allows the comparison of results with other pipelines, other industry segments, and with acceptability criteria. The algorithms are more sophisticated and flexible, allowing to better represent threats, mitigations, and other variable behavior. The probabilistic one is a type of quantitative model where data uncertainty is considered. The probability distribution is uploaded instead of single value, so the results will bring also the associated uncertainty. TBG implemented a quantitative risk model. Once selected the risk model, now is maybe the time to go to the market to find the software that best suits your needs. So TBG acquired a desktop software license designed specifically for pipeline risk assessment, not a generic risk assessment software. It starts with the connection to the database, then the quantitative model is configured in a way that it's fully verifiable and auditable. And finally, the model can be run, obtaining results for probability, consequence, and risk. As pipelines are linear assets, its variables are rarely constant along the length. So another task the software needs to perform is the dynamic segmentation, which is processing data by dividing the pipeline into sections of similar characteristics. A new segment is created when any variable changes. Only after the dynamic segmentation is concluded, the risk calculations are executed. So the results are presented in tables, formats, or graphs, or it can be exported if you prefer to see in other formats like alignment sheets. Summarizing, the pipeline risk assessment system set up by TBG is a system composed of 3 independent parts: a risk software that runs the quantitative model, connected to a server database, which is uploaded through a web application. All this work is only valid if it achieves the objectives of a risk assessment, which are provide information for risk management and for decision-making for resource allocations. However, other horizons we started to explore, associating risk assessment with class location. Based on a study with gas pipelines designed and maintained under ASME B318, the ISO 16708 proposed an acceptability criteria for the probability of failure based on the level of social risk in terms of class location, diameter, and operating pressure. When the pipeline probability is above the limit for its class location, then possible mitigations are evaluated in order to reduce it to an acceptable level. Using the mitigation module in the risk assessment software, those simulations are performed without changing the database. This can be applied, for example, to segments that had their class location increased. By simulating mitigations, this is possible to identify those measures that could provide acceptable risk levels in a higher class location. Well, this is, of course, a condensated presentation of our recent experience on this matter. And obviously, the implementation of such a system is not a quick task to complete. So I would like to leave you with this Chinese proverb: be not afraid of growing slowly, be afraid only of standing still. Thank you very much.
Thank you, Marcos. Now we have time for the questions. We already have one here for Antonio. Antonio, question for you. What is the main challenge in the implementation and maintenance of the cathodic protection remote monitoring system?
Well, the main difference is to change the maintenance static. Every month I go to EPC to control. Every 2 months I go to change to a dynamic maintenance. Then we can to dedicate our power in the pipelines have royalty problems. Sometimes we have pipelines in the middle of zones. There isn't any trains, any voltage, lines of voltage, and there aren't problems. And the static maintenance say go every month. It's not necessary if you can a remote system, because you can control these pipelines from the web. This is the difference. To attack the problems in the pipelines, we have problems.
Okay. Now for Antonio, we have another question for you, but I'm going to ask now for Alexandre.
Okay.
Alexandre, what is the most difficult step in the implementation of an IMS?
Well, thank you, Alan. The most difficult step, I would say, I've presented 5 steps, right? But I would say that the most difficult is people. Of course, within Transpet, we have outstanding integrity engineers. I'm not saying that that is the challenge. The challenge is engaging these guys on a new solution. So you have to abandon a way of doing your job and engage in a new way. Of course, when transitioning, the first steps will be slower, not as efficient, and you have to be a little bit patient. So this transition is not very trivial, right? And also everyone is busy. It's difficult to guarantee, let's say, 100 hours of training on a new tool. So I would say that engaging people is the most difficult. Of course, the data, I told data is key, and it's a lot of time consuming too. So maybe people and data, these 2 steps.
Yes. Marcos, for you, what type of risk assessment model would you recommend for an operator that does not have a lot of data?
Okay. Yes, this is a common question. People tend to believe that because I don't have a lot of data, I should start with a qualitative model or a relative indexing model. I would recommend start with the model that will be able to give you the results in the format you need. Do not choose the model based on your data. You have to choose the best model, and then you have time to go behind the data. Remember, risk assessment is a continuous improving process. So data will be improving along the time. If you think you don't have enough data now, you will get it along the years. But if you start with not good model, you will have problem in the future. That's my advise. Start with a quantitative model.
Okay, thank you. Now, Antonio, back to you. What type of communication is used by these devices?
We use normal communication by mobile phone, cellular mobile phone. It's a message, data in on time. And I know there are sometimes in Spain, no, but I remember in Mexico we have a problems in a zones in mountain zones. We have a problem. We use a satellite communications. Is normal, and sometimes in Spain we have a problems with a zones. There are better coverture with one operator, and we use two SIMs or two SIMs, no, SIMs multi-operator to guarantee the communications.
Okay, thank you, Antonio. Alexandre. I don't know if it was already answered by Marcos. Let me change. We will have a case study of the presented IMS system in the next Hill Pipeline conference.
It's possible. I cannot assure that right now. We have not yet validated the solution, the set of softwares we have adopted, but it's a possibility, yeah.
Okay. And Marcos, another one for you. How do you use international pipeline failure statistics, for example, EGIG, in your risk assessment process?
Yes, statistics are good information, especially for calibrating your model. As the model is a quantitative in absolute terms, in the same units as the international statistics are presented, we can compare our results with other companies and, of course, with international statistics.
Sorry, I'm organizing here the questions, a lot of questions for you. Another one, so I'm back again to Antonio. Antonio, is there any intelligent system for calculating the KT parameter?
Yes, the parameter is calculated in the same system. We use all the information. Now we have a mobility system, and when the operator is measurement in country, the parameter go up to the system, to the web, and every month between in the 6th day of the month, calculate the parameter KT for all the zones. And this we analyze this parameter in TAM, in value TAM, for last 12 months, and we have in the web PROCAT, in the web we have see the evolution of every zone. And you can see if the problem is a communication with web PROCAT, if I have a problem with rectifiers stopped, and another problems. But it's calculated automatically.
Okay, thank you. Alexandre, what part of the scope on data integration Transpetro has already implemented, and for which assets?
Well, our solution is based on different softwares that interconnect with each other. The main point is bring the data that is collected all along Transpetro's pipeline in Brazil and comes to our headquarters where the pipeline integrity analysis is performed. So we have different tools working together to build that. And you asked which assets, right?
Yes, which assets?
Yeah, we have selected a couple of pipelines to start with, and next year, 2022, we'll be implementing in all of Transpetro's pipeline. So the plan is to be completely integrated until next year.
So we're gonna wait till in 2023 here.
Yeah. Back in 22 maybe.
Yes. Marcos, a message here for you. Congrats on your presentation. No one is in doubt about the importance of operational risk management in the pipeline industry. Why is this discipline still very little applied systematically? What is missing?
Oh, I think that Alexander have answered this before. There is a integrity management, risk assessment. Our management systems are always a new culture, and always implementing a new culture is difficult. Change is difficult. All the difficulties related to any change are in the implementation of risk assessment and integrity management. The barriers to change, to move to another way of working, I think this is the main reason. Change culture in pipeline operators is not easy. Your microphone is closed.
I'm sorry. Alexandre, another one for you. How can you integrate inline inspection data from different vendors into the IMS? Do vendors need to deliver reports in a standard format? Do they accept to do it?
That's a good question. We have been dealing with this issue manually, I would say, for the last years. So we actually receive in different reports in the different formats. And one of these aspects that I mentioned about data maturity is the data to be repeatable or standardized, right? So the aim here is to be standardized. And when you have to manipulate it manually, it can lead to errors, human errors. So actually, we have been developing a solution within Transpetro with our own resources to deal with this problem on a tool developed within Transpetro. But ideally, the integrity management software would deal with that issue, right? If it can learn that different tools have different roles for each data, you would be automatically inputting this data. So ideally, you can inform your different formats for the IMS, and you can keep the vendors with their standards, okay, if your software allows it. That's one solution. I've seen that the vendors have trouble when you ask them to change the formats because they already have their system developed. It takes an effort for them to modify it. So it seems to me at first that it's easier for the IMS to adapt than the vendors to adapt. But maybe in the near future, we'll have to go to the vendors and ask for any changes. It's a possibility too.
Okay, let's to the last question for you, Antonio. Does NetHEA experiment natural gas leaks? If yes, how do you monitor and manage that data?
I'm sorry, I don't understand well.
If you experiment, if you have natural gas leaks, if yes, how do you monitor and manage that data?
Yes, we have a system. We monitoring all the pipelines, and we do maintenance for detection the leaks in different all the country. And now we are on a new project, a product owner of the maintenance, the dynamic maintenance, because the rule say, for example, we every 2 years to maintenance the pipelines in the zone in the urban zones every 2 years. And it's possible you can build a new pipeline in January, and in August you ought to do the maintenance on this pipeline. It's not efficiency. And we work in a new project for monitoring for the dynamic this pipeline. But it's in we begin this year, and now don't have results, concrete results. We have in the middle of the project now.
Okay, thank you. And Marcos, the last one for you. We have now 4 minutes, less than 4 minutes to finish. We have a question here. Marcos, I understand that the software you presented is only at risk. If this is correct, how do you manage it to integration with integrity assessment? Do you want to repeat, Marcos?
Okay, no, I got it. Well, as I said, the database is an open database, so it's not difficult to share the results or using the results of other systems if they are connected to the same company's database. At the moment, we didn't implement an integrity software as a whole. We have only, by now, the risk assessment model running in the company. But it's prepared to be connected with any other product, since the database can be shared.
Thank you. So I'm going to finish with these questions because we are almost finishing our section. I want to thank Antonio, Alexandre, Marcos. Thank you, IBP, for inviting me again to mediate this section. And we have more 2 sections today. Critical stages in the implementation of new onshore pipelines in Brazil and offshore gas production in Brazil, main current challenges. Thank you, the audience. Thank you very much.